Using the derivative to find velocity and acceleration. Rate of change. The rate of change of position function s of t over interval t1, t2 is s of t2 minus s of t1 over t2 minus t1. Instantaneous velocity at t1 is the first derivative of the position function s of t1. Instantaneous velocity at t2 is the first derivative of position function s of t evaluated at t2. A ball is dropped from the height of 360 feet. The ball's height y at time t is given by the position function y of t equals to minus 16t squared plus 360, where y is measured in feet and t is measured in second. So let's find the average rate of change of the function over the given interval 4, 4.1. So first we find y of 4. So let's write down the position function y of t equals to minus 16t squared plus 360. So substitute t equals 4. So this becomes y of 4 equals to minus 16 times 4 squared plus 360. Now 4 squared is 16 times 16, maybe minus 2256 plus 360, which is 104. Now find y of 4.1. So we substitute 4.1 in y of t equals to minus 16t squared plus 360. So this becomes y of 4.1 equals minus 16 times 4.1 squared plus 360. Now you simplify and get 91.0 feet. So we have found y evaluated 4.1 is 91.04 and y value evaluated at 4 is 104. Now we write the average rate of change, which is y evaluated at t2 minus y of t1 over t2 minus t1. Now we substitute t2 equals 4.1 and t1 is 4, and the average rate becomes y of 4.1 minus y of 4 over 4.1 minus 4. Now we substitute y of 4.1 91.04 and y of 4 equal to 104. So this becomes 91.04 minus 104 over 4.1 minus 4. We simplify, it becomes negative 12.96 over 0.1, which becomes negative 129.6 feet per second. Interpretation is negative average rate means object is moving downward. So for the position function y of t equals to minus 16t squared plus 360, we're going to find the instantaneous rate of change at the endpoints of this interval. So first we find instantaneous rate of change at t. Let's start with y of t equals to minus 16t squared plus 360t. So we'll differentiate with respect to t, and y of t becomes y prime t, and this becomes d over dt of minus 16t squared plus 360. Now we use the sum rules of differentiation, so we can break it down into two derivatives, d over dt of minus 16t squared plus d over dt of 360. Now we differentiate using the combination rule, d over dt of c times t to the n is equal to cn times t to the n minus 1. So this becomes minus 16 times 2, t to the 2 minus 1 becomes t, and 360 is constant, so the derivative is 0. So we simplify and become negative 32t. The instantaneous rate of change at t we found is y prime t equals to minus 32t. Now at the left hand point, t equals to 4, the instantaneous rate is y prime t equals to minus 32, so we substitute t equals to 4. So this becomes y prime of 4 equals to minus 32 times 4, which is minus 128 feet per second. Now at the right hand point t is 4.1, so the instantaneous rate of change, which is y prime t equal to minus 32t, so we substitute here 4.1 and simplify, you will get minus 131.6 9.2 feet per second. If s of t is a position function of t, then velocity v of t equals to s prime t is the velocity function, and a of t equals v prime t, or a of t equals s dot prime t is the acceleration function. So example 2, a projectile is shot upward from the surface of Earth with an initial velocity of 240 meters per second. Use the position function yt equal to negative 4.9 t square plus v naught times t plus s naught. V naught is the initial velocity and s naught is the initial position. So V naught is 240 and S naught is 0 on the surface of Earth. So let's write down the position function, which is y of t equals to negative 4.9 t squared plus V naught times t plus S naught. Now we substitute V naught equal to 240 and S naught equal to 0. So the position function becomes y of t equals to negative 4.9 t squared plus 240 t plus 0. We simplify and we get y of t equals to negative 4.9 t squared plus 240 t. Now we differentiate with respect to t. Okay, so we differentiate the position function y of t, and we have y prime t equal to d over dt of minus 4.9 t squared plus 120 t. Now we use the sum rule of differentiation, and we have y prime t equals to d over dt of minus 4.9 t squared plus d over dt of 120 t. Using the combination rule, d over dt of c times t to the n is c times n times t to the n minus 1. So if you apply this rule on this one, becomes negative 4.9 times 2 times t. And this becomes 120 times 1. So now we simplify, gives you negative 9.8 t plus 120. Velocity at instant t is now v of t equals to y prime t, which is minus 9.8 t plus 120. Now we're going to find the velocity at t equal to 10 seconds. So we substitute 10 seconds into v of t equals to minus 9.8 t plus 120. So this becomes v of 10 minus 9.8 times 10 plus 120. So we simplify, this becomes minus 98 plus 120, which is 22 feet per second. Example 3. The position function of an object in meters is s of t equals to 36t minus 1 over 3 t cubed, and t is between 0 and 6. We're going to find the velocity and acceleration of the object when t is equal to 2. So let's start with the position function s of t equals 36t minus 1/3 t cubed. Differentiate with respect to t, so s of st becomes s prime t. So this will d over dt of 36t minus 1/3 t cubed. Now we can apply the difference rule of differentiation. So we break it down into two derivatives, d over dt of 36t minus d over dt of 1/3 t cubed. Now the derivative of 36t is simply 36 times 1, and the derivative of 1 over 3 t cubed, we can apply the combination rule, and that will be 1/3 times 3, and the power of t becomes 2. So now we simplify, so 36 times 1 is 36, 3 cancels with 3, so it will be minus t squared. Okay, the velocity v of t is the s prime of t, and s prime t we found 36 minus t squared, so therefore velocity at t is equal to 36 minus t squared. Now to find the velocity at t equals 2, we substitute t equal to 2. So this becomes v of 2, 36 minus 2 squared. And 2 squared is 4, so 36 minus 4 is 32 meters per second. Now acceleration a of t is defined as the first derivative of et. So this becomes d over dt of 36 minus t squared. Here using the difference rule of differentiation, we can break it down into d over t of 36. a minus d over dt of t squared. Now derivative of 36 is 0, and this derivative of t squared is 2t. So a of t is minus 2t. So now to find the acceleration at t equal 2, we substitute t equal 2. So this becomes minus 2 times 2, minus 4 meters per second. The end. Thank you for watching. Subscribe. It is free, but will get you our next video fast.